today's lectures we have discussed the topic alcohols. In this topic we have seen first points the classification of the alcohols. Classification of alcohols. Alcohols are classified according to the number of carbon atoms is attached to the OH group, and therefore is classified into three types. First one, primary alcohols. Second type, secondary alcohol, and third type is tertiary alcohol. Tertiary alcohol. So classifications of the alcohols are classified into three types: primary, secondary, and tertiary. It is also designated as this is types 1, 0, secondary, and it also tertiary alcohols. Now we have seen these examples for primary, secondary, and tertiary alcohols. One by one are here. First, primary alcohols like this is a primary alcohols. Name is N-propanol. N-propanol. It is chain alkanes or the 1-propanol. So this is the name for these alcohols. Another examples now we have seen are here for primary alcohol is like it is also primary alcohols, methanol. Third examples one, two, three, four, and 5 carbons are there. So 1-pentanol. It is also a primary alcohol. Now we have see the secondary alcohols. Examples of secondary alcohols are here like this. Because the OH group is attached to the second carbons. So 1, 2, and 3. It is a isopropanol. It is a common name, isopropanol. Or IUPAC name is 2-propanol. Or another type, propane 1-ol, right? Propanol. Another examples like this. What is the name? 1, 2, 3, and 4. So second position having the OH group. So this structure's name is 2-butanol. Right? This is a secondary alcohols. Then we have seen next examples like tertiary alcohols are Yes. This is a tertiary alcohols. So what is the name? Tertiary butyl alcohol. Tertiary butyl alcohols. Now we have seen the type of alcohols like monohydric alcohols, dihydric alcohols, trihydric alcohols, which are important to us to moving our knowledge, like dihydric alcohols. It is a ethylene glycol. Ethylene glycol. It is glycerol. This is name is a glycerol. It is a dihydric alcohols. It is a trihydric alcohols. And next, polyhydric alcohols. Polyhydric alcohols are like a sorbitol. Sorbitol. The structures are like this. Four times CH2OH. It is a polyhydric alcohol. Name its example sorbitol. Dihydric alcohol ethylene glycol, and trihydric alcohol like glycerol. So this is some examples which are important to us, our knowledge. Next point, we have see the method for the preparation of alcohol. Now we have first methods. We have CR here for the preparation of alcohols by using hydration of alkenes. Hydration of alkene. This is the first method we are used to prepare alcohols. In this method, like these general alkenes, we can treat with water. Treat with water in acidic conditions, and then get the corresponding alcohols, right? So this is a general reaction for the preparation of alcohols. Similarly, other example we have take like this. Ethene in presence of water at acidic conditions, then to get the product is primary alcohols like this H plus. Okay, so CH3 CH2 OH, this is a product. And which type of alcohols? It is a primary alcohol. What is the name? 2 carbons, therefore ethanol, 1 ethanol, that is the product. And therefore such type of preparation of alcohols, accordingly Marconi's addition. You know Marconi's addition? The negative part of abundance which is attached to the less number of hydrogen atoms, and hence hydration of alkenes, it does not produce the primary alcohol except only ethene. we have used other alkenes, that is unsymmetrical alkene. Thus times to get the product is a different respective alcohols, but only and only we are used as a ethene molecules. Thus times to get the product is only primary alcohol by hydration of this ethene. Next molecules, now we have Cr here, like unsymmetrical alkene we have take are here like this. Next times they will create the different alcohols in presence of acidic conditions. What will be there the products? This H plus is attached with this because we can take these products H plus. Then what happens? Break this carbon-carbon double bond and convert to carbon-carbon single bond are here like this. Right? And after breaking of this bond to form the carbocation are here. Right? Sorry. One of the hydrogen is more. So this formation of carbocation are here. This carbocation is a tertiary carbocation, and you know that the tertiary carbocation which are more stable than secondary, and secondary is more stable than primary, and hence tertiary carbocation are more stable, and therefore remaining water molecules will attack on this carbon, and to get the product is alcohol. Which type of alcohol? It is a tertiary alcohol we get the products. Right? So it is the different type of alkene we have take by hydration in presence of acidic conditions to get the corresponding alcohols. And therefore what is the name? Name is the tertiary butyl alcohols, right? Tertiary butyl alcohol. Similarly, the alkene when treated with the dilute H2SO4, concentrated sulfuric acid in the form of alkene, cold concentrated sulfuric acid. Now other examples we have Cr here with the alkene in presence of the cold concentrated H2SO4, cold concentrated H2SO4. That times what type of reaction can be done? We are C is here. For example, these general alkenes we have taken in presence of the H2SO4, cold H2SO4, concentrated cold H2SO4. Then the product which is obtained like the alkyl hydrogen sulfate. The product is alkyl hydrogen sulfate. What type of products? CRS, like one of H is here and second type is SO3H is here. This is a alkyl hydrogen sulfate, and then after this alkyl hydrogen sulfate molecules we can hydrolyze with water to get the corresponding alcohol as the products. Like by using this water hydrolysis to get corresponding alcohol as the product. Okay, this is a general type of reactions. Now we have take the examples of other alkenes in presence of cold concentrated H2SO4 like ethene plus H2SO4. Then what is the product? Product is CH2H, CH2, SO3H, right? And then after formation of this, it is alkyl hydrogen sulfate. Then H2O hydrolysis to get the product is SO3H replaced by the OH. So product is CH3, CH2 and then OH. Product is ethyl alcohol. Right? For example, okay, H2SO4, then what is the product? CH3CH, SO3H, CH3, and then after water hydrolysis. But why SO3H is added here? Because according to Marconi's addition reaction, negative part attached to the less number of hydrogen atoms. It is less number of hydrogen atoms, and hence the negative part of SO3H is attached these second positions. And then after hydrolysis, this SO3H group can be replaced by OH to get corresponding alcohol as secondary alcohol. Like this. So what is the name? 2-propanol as a product. Now we have to take other examples. Hydroboration reaction. Hydroboration oxidation reaction. Hydroboration oxidation reaction. It is a anti-Marconi's addition reaction. Anti-Marconi's addition reaction. According to Marconi's addition, the negative part which is attached to the less number of hydrogen atom. But anti-Marconi's addition reaction, the negative part which is attached to the more number of hydrogen atoms. So hydroboration reactions mainly used as a diborane like B2H6, but in the reactions are used as the borane like this BH3. And then after oxidation using hydrogen peroxide to get corresponding alcohols. We have seen in details. Firstly, we have take the general structures of alkenes, right? 3 molecules of alkenes. We have add the borane. Then to get the product is trialkyl borane as the product. R CH2 3 times borane. And then this borane, trialkyl borane, can treat with H2O2, hydrogen peroxide. Then what happens? To get the product is trialkoxyborane. Trialkoxyborane, R CH2 CH2O 3 times borane, trialkoxyborane. And then this trialkoxyborane we can hydrolysis with aqueous alkali like NaOH to get corresponding alcohol as primary alcohol, R CH2 CH2 then OH as the product. So such a type of steps can include in hydroboration oxidation reactions. Now we have see are here some examples of hydroboration reaction is, right? Such type of alkenes we can treat with the borane to get the product is corresponding alcohol as CH3 CH2 then CH2OH, primary alcohol as the product. So what is the name? Propanol, 1-propanol. Next we have see other examples like the propene we have propene. Second example, ethene, CH2 double bond CH2. In presence of such type of reagents like borane BS3 in presence of THF, hydrogen peroxide H2O2 OH minus, THF as a solvent, tetrahydrofuran. Then what is the product? Product is CH3 CH2 and then OH, primary alcohol as the product. Accordingly, anti-Marconi addition reaction, because the negative parts OH attached to the more number of hydrogen atoms are here to get the primary alcohols only in hydroboration oxidation reactions. And the product is the ethanol. 1-ethanol or other type of reaction name is given like ethane 1-ol, ethanol. So this is some examples of hydroboration oxidation reactions. Next we have take other examples for such hydroboration reactions is like this. In this reaction, the 3 molecules of this alkene we have take by using borane at tetrahydrofuran, hydrogen peroxide at oxidation and hydrolysis by using aqueous OH to get the corresponding alcohol as CH3 CH2 this CH2 CH2OH. How many carbons are there? 1 2 3 and 4 carbons are there, and this one is key to attach only OH are here. Product right is very simple. 4 carbons are there. These 4 carbon right as it is only one OH group is attached to here. This is primary carbons and name of this alcohol is 1-butanol or butane 1-ol. Okay. So this is the two methods Now we have CR here for preparation of alcohols. First one, hydration of alkenes, and next one is a hydroboration oxidation reaction. Okay, thank you.